Today we're talking about operations of matrices. And so the first operation we're going to talk about is addition. And so when adding matrices, your matrices must have the same dimensions. So, an example if we have the matrix which we're going to call matrix A, and we want to add the matrix which we're going to call matrix B, we want to say first, is this possible? So to determine if it's possible, it tells us right here that they must have the same dimensions. So we're going to say, okay, what are the dimensions of matrix A? Well, we have 1, 2, 3 rows and 1, 2 columns, so this is a 3 by 2 matrix. Then if we go over to matrix B here, we have 1, 2, 3 rows and 1, 2 columns, so it's also a 3 by 2 matrix. So these are the same, so we can add. So let's add. To add, what we're going to do is we're going to say, okay, we're going to do row 1, column 1 plus row 1, column 1. So we're going to do 3 plus 4, which will give us 7. Then we're going to say, okay, row 1, column 2 plus row 1, column 2. So 2 plus 3 gives us 5. And we're going to continue this pattern by adding them together. So 2 plus 5, 4 plus 1, 6 plus 6, and 5 plus 4. So our answer matrix, which we're going to call matrix C, is now solved for, and the dimensions of matrix C is also 3 by 2 because we have 1, 2, 3 rows and 2 columns. A quick little side note you're going to want to make sure you write down is that if a matrix A doesn't match the dimensions of matrix B, then the sum of matrix A plus matrix B is undefined. The next operation that we're going to talk about is subtraction. And so in subtraction, it's similar to addition, where your matrices must also have the same dimensions. So if we go ahead and do an example, we're going to say matrix, which we'll call matrix A, minus which we'll call matrix B. And the first thing we need to do is determine, can we subtract these by finding the dimensions. So if we start with finding the dimensions of matrix A, we have 2 rows and 2 columns, so it's a 2 by 2 matrix. And the 2 rows and 2 columns for B as well, so also a 2 by 2 matrix, which means these are the same, and we are able to subtract. So we subtract. So we're going to say, okay, 3 minus 2, because row 1, column 1 minus row 1, column 1, is going to give us 1. Then we're going to say, okay, 6 minus 7, because row 1, column 2 minus row 1, column 2, is going to give us negative 1. And then we keep on going. So 4 minus 1, and 6 minus 9. And so we get this matrix here as our answer, which we will call matrix C. And if we look at matrix C here, we see here, didn't mean to do that, but we see here that it is also a 2 by 2 matrix. So we want to go ahead and make ourselves a note that is actually going to be similar to our last note. So if matrix A doesn't match the dimensions of matrix B, then the difference of A minus B is undefined. Ooh. Our next operation that we're going to look at is multiplication. Where matrix A of m by n and matrix B of n by p are able to be multiplied. And so if we take these dimensions and we write them down, so if we take matrix A, which was m by n, and we take matrix B, which was n by p, you're going to want to make sure that you notice that these two portions of the matrices are the same. And so the columns of matrix A are the same amount as the rows of matrix B. And so make a note for yourself if these are not the same, your answer is undefined. All right, and so if we go back here, the m here and the p here, that creates the dimensions of your answer. So now if we go to an example, So if we take this matrix here, which we will call matrix A, and we want to multiply that by which we'll call matrix B. And so first thing we need to do is check our dimensions. And so if we look at matrix A, it has 2 rows and 1, 2, 3, 4 columns, so it's 2 by 4. And then if we check the dimensions of matrix B, we have 1, 2, 3, 4 rows and 3 columns, so it's 4 by 3. And remember the middle pieces in here? These need to be the same, and they are the same. Therefore, we can multiply our matrices. And so we also want to remember that the outside portions here create our answer dimensions. And so we know that our answer, which we'll call matrix C, is going to be a 2 by 3 matrix. So I'm just going to kind of fill in an empty matrix for right now and know that it's going to be a 2 by 3 dimensions in matrix C. So now we want to go ahead and multiply these. So when we do this, we're going to say, okay, I'm just going to draw some brackets, and we're going to start with row 1, column 1's element of matrix C. To find that, you're going to have to take row 1 of matrix A and multiply it by column 1 of matrix B. So we're going to start, and we're going to say, okay, this times this. 1 times 1 is 1. And then we're going to add 4 times 2, because we're going over 1 in the row and down 1 in the column, and that's 8. And then we add 6 times 9, which is 54. And then we add again, and we're going to do 10 times 3, which is 30. I like to put parentheses around that so I know all of that goes to one entry in the new matrix. All right, and so now we're going to move on. So I'm going to do some erasing here just so that you can see as I move forward. And I'll rewrite it in for you, don't worry. So now we're going to move on, and we're going to do row 1, column 2 of matrix C. So we're going to take row 1 times column 2. And so let's go through this again. We're going to do 1 times 4, which would be 4, plus 4 times 7, which would be 28, plus 6 times 0, which would be 0, plus 10 times 1, which would be 10. And again, I'm going to put parentheses around that so I know it's all the same element. Okay, so now we're going to move on again, and now we're going to do row 1, column 3. So row 1 times column 3 here. So we're going to do 1 times 6, which is 6, plus 4 times 5, which is 20, plus 6 times 11, which is 66, plus 10 times 0, which is 0. And then I'm going to put parentheses around that. And then that's going to be where the end of our matrix would be because we've gone through all 3 of our columns. Now we have to do this for the second row of matrix A and all 3 columns of matrix B. So 2 times 1 is 2, plus 7 times 2 is 14, plus 5 times 9 is 45, plus 3 times 3 is 9. Then 2 times 4 is 8, plus 7 times 7 is 49, plus 5 times 0 is 0, plus 3 times 1 is 3. And then lastly, we're going to say, okay, 2 times 6 is 12, plus 7 times 5 is 35, plus 5 times 11 is 55, plus 3 times 0 is 0. Now we're going to add everything together. So we're going to say, okay, right here, added together gives us 93 in matrix C, and then right here is going to end up giving us 42. Then here gives us 92. Then down here gives us 70. Here gives us 60. And right here gives us 102. And that would be our final answer for matrix C. And then the last one we're going to do is scalar multiplication. Which is when you're going to multiply a constant, which I'm going to call K, by each entry of the matrix. So if we do an example, I'm going to take the constant of 2 times the matrix, and so I'm going to start with saying 2 times 4 is 8, 2 times 0 is 0, 2 times 1 is 2, and 2 times negative 9 is negative 18. And so right here is our final matrix answer.